I bought this almost 60-year-old outboard motor for $50, and in the previous video I found its three main problems. Only one of the three cylinders was working, a failed cooling water pump, and the third problem is a stuck shift lever. So let's try to fix these problems. I'll start with the dead cylinders and check if they're getting spark. The second and third cylinders have no spark, so I suspect the ignition coils are the problem. Judging by the condition of the metal parts and the mounting bracket, I wouldn't be surprised if it's just a bad electrical contact. I'll spray them with contact cleaner and let it work. In the meantime, I'll take a look at the water pump and the stuck shift lever. To get to the pump, I need to take apart the lower unit. But before I can remove the lower unit, I need to disconnect the shift linkage. To disconnect it, I need to loosen this screw, but with the shift linkage stuck like this, I can't get to it. So I'll try cutting it off. According to the parts diagram I found, nothing else should be holding the lower unit on, so it should come off. But it still won't come off, so I'll try disconnecting it at the top right under the engine. I also need to remove the rubber mount from the midsection. After a long fight, I feel like I have nothing left to lose. Time for a chisel and a hammer. It's honestly a miracle nothing cracked after all that hammering with the rubber mallet. And now it's clear what the problem was. A rusty metal coupling was holding the shaft in place. And the shift linkage, it's stuck right here in this passage. The leg sections took a lot of damage from the cold chisel, but I can fix that with metal epoxy. Now I can finally check the water pump and see what failed. The rubber impeller is completely destroyed. Maybe it was those 20 years of sitting unused, or maybe my attempt to start it without water finished it off. And then this happened. Luckily, the only thing that broke was the starter bracket. But even so, it's a part I probably won't be able to find anywhere. The threads for the starter bolts are stripped out. So I have no choice but to make a new starter bracket. The new bracket looks right. I'll test it later. And now, back to the lower unit. Seeing the condition of this shift rod seal, I might as well replace all the seals and bearings while I have it apart. I'm already starting to regret this idea a little, but this last screw won't stop me. I'm honestly surprised there's still some oil in the gearbox. The gear oil looks milky, so water probably got into the gearbox. That means the seals definitely need attention. Surprisingly, the gears still look almost brand new even after nearly 60 years. It's definitely time to replace these seals. And this bearing is completely destroyed, only the inner race is left, so it has to go too. And this thrust bearing is done too. And here's the rest of the bearing that fell apart on the shaft. Luckily, the bearing seat is almost untouched. The bearings and seals are replaced. Now I need to fix the stuck shifting mechanism. This is the shift lever and the toothed mechanism that prevents gear changes at higher RPM. Using a few washers and a nut, I'll try to push the rod out. That didn't move the rod at all, so I'll remove the engine from the rest of the leg and drill the rod out. Good thing I removed the engine. This rubber mount is destroyed. The passage is clean. Now I'll make a new shift rod. I'll straighten and repair the shift lever and the tooth mechanism so they sit better on the shift rod. Damaged joint edges. I'll repair them with metal epoxy. Since it's already this far apart, I'll sand all the parts and spray them with 2K paint. Some of the rubber mounts are broken and I couldn't find replacements for them, so I bought rubber mounts without bases and I'll make the bases myself. There's a lot of play in this shift linkage pin that could make shifting inaccurate, so I'll make a new one. I'll install PTFE bushings in the shift rod passage so the rod won't seize again. I'll also replace the rubber mounts under the engine. Now the only thing left is to fix the water pump. First, I'll remove the burnt-on rubber from the inside walls. I managed to find a new impeller. The only dimension that's different is the height. The new one is 1 millimeter shorter. So I'll make a stainless steel shim and place it inside the pump to make up for the missing millimeter. To keep it from moving inside, I'll glue it in place. I'll lubricate the impeller with dish soap and put it in place. A little over half a liter, about 17 fluid ounces of gear oil. Before I put the leg with the water pump back on the engine, I'll check the cylinder compression, as many of you recommended in the comments on the previous video. All cylinders showed around 4 bar, about 58 pounds per square inch. Could the low reading be caused by the missing fuel oil mixture, which normally helps seal the rings a little? Now, back to the ignition coils. Based on many similar comments on the previous video, I'll take one ignition coil and use it to test the power feeds for each coil. Only the first coil feed seems to be getting an ignition pulse. The first obvious problem is this burned wire on one of the condensers. I'll clean the ignition points and insulate the wire. And I'll also test the condensers. Their resistance should gradually increase. And I'll set the breaker points to 0.35 millimeters. Problem solved. I cleaned up the starter and the other parts and gave them a fresh coat of paint. Before I put the leg back on the engine, I'll thoroughly grease the shaft coupling so nobody ever has to deal with a stuck lower unit again. I'll reconnect the shift rod. And I'll also test the shifting. I'll apply glycerin to the rubber to bring back some flexibility and slow down further drying. I'll spray a little fuel oil mix into the cylinders so it doesn't start dry before it gets fuel. I made a small switch panel for the engine to start it, control the choke and turn the ignition coils on and off. For this test, I mixed the fuel at 1:40. It took quite a while before water started coming out of the telltale. But after a short while, it stopped flowing again. Even though there's less oil in the fuel, it still smokes quite a lot. But it revs up really nicely. The shifting is still nice and smooth, and it even looks like it's charging the battery. The starter bracket turned out great too. Based on the coil shut-off test, all cylinders are working. But the cooling water, it still isn't circulating. The impeller spun on the shaft key, and the key carved a round groove inside the plastic. The original impeller had a brass hub. According to the parts diagram, the original should use a woodruff key, but here there's only a small piece of round bar. I'll try adding 2 more pieces and rotate the impeller. The shaft spins freely, so the impeller shouldn't be causing much friction. Okay, the water came out much faster this time, but then it was the same story again. My last hope was a clogged telltale. If that was the problem, I should see water at the thermostat housing. Okay, so I need to find an impeller with a brass center hub. And how does the engine sound at idle with the cover on? And I'm still missing one thing, the thermostat and the little screen that goes with it. If anyone knows which engine uses a thermostat that fits here, please let me know in the comments. Thank you.